My name's Bob. For those of you that don't know me, I think I really only see about two people in here that I see on a regular basis. So the rest of you, welcome. I'm the principal of Mastery Analytics. If you have any questions about anything that we're talking about this evening, please feel free to go ahead and email me at bob@mastery.net. Also, you can follow me on Twitter. My Twitter feed is all about data. There's no pictures of my cat on there or anything like that. I absolutely promise. Okay, so I've been working in data for the past probably 14 years at this point. I've been working in analytics specifically for the past 3 or so. Last year, I opened up Mastery Analytics as a data consultancy. It's a data consultancy, not a big data consultancy. I don't care if it's big or small. I can work on your data problems. But I opened up Mastery with one idea in mind, and that's we can be doing data better. Okay, I am on kind of a mission to fix that because there's so many times I walk into organizations and their data architecture will look like something that Rube Goldberg designed. And I think that all stuff, yeah, that can be fixed definitely. So I'm currently rolling solo. I plan on hiring people probably later this year, and then once that happens, I will be on my way to global domination. So watch out. Yeah. So, exactly. So I'm going to be talking about three things tonight, right? I'm going to take these three concepts and I'm going to string them together in a way that you guys can see how you can actually make real time data actually work. Is there anybody right now in here who's working on anything real time in their organization? Real time systems? Anybody? Bueller? Nobody. All right, good. That I understand that real time is actually difficult, and the reason for that is well, I'm going to talk about it later. Okay. What we're not going to talk about. So one of these we're going to talk about is in-memory databases. Um, in-memory databases, all the solutions that we're going to take a look at are distributed systems, and they all work on the underlying distributed systems theory. If you're not familiar with distributed systems, I'm happy to talk about that, but that's another half an hour conversation I'm happy to come back and do at some point, but we don't have time for it tonight. The other thing is that in-memory tech is completely new to me. According to Raj, I guess memory database has been around for a while, so I can't go back and say, well, it was horrible, but now it's awesome. All I know of in-memory databases is that they're awesome. So I can't do that compare and contrast for you. Okay. First concept, HTAP. Okay, new word. It got coined by Gartner about a year ago, about this time last year. Pretty basic concept. What we've been doing for the past decades and decades, is that we've been taking data out of our transactional systems and we've been shoving it in the data warehouse through some complex ETL batch process. What HTAP basically says is that instead of doing that, just do all your analytics and all your transaction processing in one database. Not a new concept, but the tech really is not there to do it the way that you really like to do it. And the problem for that is something that we've all dealt with is that you've got reads and writes blocking each other, right? Short reads, no big deal, but those long analytic reads that like run for 5 minutes is going to be a problem for your writes, right? So tech is really not there to handle that. These are the challenges that are tackled by HTAP, right? Um, if you talk to me for any length of time, you'll find out that ETL to data warehouse, so that batch process is kind of a it's my pet peeve. I absolutely hate it. I hate slow batch processes. So the idea that we can get rid of that, it really, really excites me. I want to go ahead and point out that fourth bullet point, though. These are Gartner's bullet points. These aren't mine. And the thing about distributed systems is that all of them replicate data. So I'm not entirely certain what Gartner was trying to aim for with that last bullet point. I just wanted to point out that inconsistency in my presentation. Okay, so what is real time? So I am super literal, right? You come to me and you say real time, and I automatically assume you mean like instantaneous right now, like zero lag right now. Obviously, that's not very practical in the real world. Hey, um, Jesse, go ahead. Okay. Obviously, that's not practical in the real world, especially when you have those use cases where you've got human beings that are looking at data where it's okay to have just a little bit of lag, like maybe 1 or 2 minutes, because the human has to stop and think and take a look at what's actually going on. In those cases where you only have 1 or 2 minute of lag, I think that's completely okay to just go ahead and call it real time. That's close enough. It's not 24 hours, so big improvement. Hey, why do you want to do real-time analytics? Normally at this point in the presentation, I talk about this stuff a lot. I talk about a guy named Colonel Boyd. I talk about OODA loops. I talk about decision cycles, and I talk about how shooting down fighter planes is kind of like being in business. And I don't really think I need to have that discussion anymore. If you are paying any kind of attention to your career right now, then you know when it comes to analytics, those who make decisions fast wins, right? And even if you really don't get that academic with it, the reality is that most managers that I work with want their data right now, if not yesterday, because right now isn't quite fast enough. And then there's our friend, the IoT, the thing that's coming at us that we're all going to have to deal with, all this deluge of machine data. In my mind, IoT is, by definition, real time, right? We can sit here and actually talk all night about use cases for real time. What I really want to talk about is the more radical concept of everything being real time, right? And so this is what that looks like. If instead, when you're doing your batch process in your data warehouse, instead of thinking about pulling the data out of the table, think about the transaction log that's actually taking place as these events occur in your database, right? Because what that log is basically recording all these events, all these changes that are happening in time. Okay, I think most people kind of understand this intuitively, but you might not have a framework of how to think about that. So if you don't have that framework in your mind, I highly suggest you go out there and you read I Heart Logs. It's a very short book. It was actually a blog post written by a guy named Jay Krebs. If you don't know who that is, he's the guy that wrote Kafka while he was at LinkedIn. And there's two basic takeaways from this book. Number one, the log is the unifying abstraction for transporting data around your organization. And the other takeaway is that what you need to do is you need to develop a standardized log format for your organization, right? So we've got this thing right here, the Rube Goldberg machine. And what do we got? We got sinks and sources of data. All these sinks and sources have their own APIs. If you want to move stuff around, you have to write to that API, and that winds up you having to write a custom pipe between like Espresso and your email, your data warehouse, the user tracking, et cetera, et cetera. And it just looks like a mess. And we do this because we don't have, any better idea, except Jay Krebs did have a better idea. If you do the two things that Jay Krebs talks about, you can take a data architecture and make it look like this. So instead of having to write to all these separate APIs and whatnot, what you can do is you can just write against your unified log process, which in this case he's abstracted it a little bit, but the unified log is probably going to be kept in Kafka or something like that. So makes things super simple, and super simple is what you need, what you want to do real time. Okay. This is how I see real time doing in the real world, right? So Cerner, which is like winning the real time game in this town pretty much, has a Kafka Swarm Hadoop cluster, and they came and talked about that like our very first meetup, as a matter of fact. I think they suck in, I think it's claims data. It hits Kafka, it hits Storm, and then goes off their Hadoop cluster, and like the lag is like less than a minute, which is awesome. But it's in Hadoop, which is like not awesome because Hadoop has its own challenges and issues in terms of dealing with the data that's in that data source, right? I have another client that is doing SQL Server replication. What they do is that they take their transactional database and they replicate it down to a different database. So basically, you're not hitting the transactional database with those long, running analytic processes, and their lag's 5 minutes, and that's completely okay for them. And then there's my absolute favorite, another client who their approach to real time was to take a normal complex warehouse load and just run it every 15 minutes, which might have been legit, except for the fact when the job runs more than 15 minutes, you've got multiple instances of that job running. So, yeah, that was fun. It did not work. So, so you want to do real time analytics? That's cool. Um, you have to sell out to one critical idea, and you have to sell it out to yourself, and you got to convince all your coworkers that this needs to be done. Then you have to go and talk to the guy at the paycheck and convince him that what you actually have to do is get rid of some of the things that are in your architecture and get brand new stuff, because you can't do real time analytics really with 20th century technology. The normal relational databases, the monolithic servers, it's not going to work, as we've already seen with that SSIS job, right? This is where in-memory databases come in, right? So they've been around for a very long time, like from the 60s, as a matter of fact, just the concept. But that has caused some confusion in the marketplace about what an in-memory database actually is. If you've got a caching layer in database, which is what like a lot of database vendors do to try to speed things up, that's not legit. That's not an in-memory database. Your data has to be residing in the main memory of the machine for that software to be considered in memory. That's straight from Gartner. Okay, so when I was taking a look at the whole problem of trying to do rapid ingest, right? Because if you're going to do real time, you need to be able to suck in data really fast. These are the databases I was taking a look at. I'm actually going to go from the bottom up. So there's Cassandra, which I love Cassandra. I still love Cassandra, but here's the thing. I attended a training by DataStax last summer, and basically they said flat out, Cassandra's amazing for rapid ingest, but you don't want to use it for analytic workloads. And I'm like, what? Why not? Well, they said if you do that, you kind of miss the point of Cassandra. Like, okay, I kind of shook my head and just went on. There is Netezza, then there's Microsoft SQL Server Parallel Data Warehouse. I think AMC runs Netezza, and PDW is actually at the Fed, as a matter of fact. And I know both those people are very happy with their implementation. They're cluster databases. Here's the thing: they're actually appliances. They're warehouse appliances, so it's not just a software solution; it's a hardware solution as well. So what happens is Microsoft comes into your place of business, drops off a bunch of boxes. They're going to go ahead and manage it. So IT is not even involved in it. So IT loves it. The analysts love it because it's basically SQL Server. And so from their perspective, it's not any different from what they're normally dealing with, except their queries are sped up. Sounds fantastic. Here's the catch. I've got a buddy that's getting ready to do a PDW implementation, and he says that Microsoft has got that bad boy priced out at like $500,000. So if you got $500,000, go ahead and write the check. Sounds great. But if you want a cheaper solution, there's other options out there like MySQL Cluster. Did anybody even know that MySQL Cluster had a cluster version? I just found this by it's been around since 2012, but I just found it by accident like a month ago. And then here's a really interesting thing. I went and fact checked my slides last night, and at first it was just a cluster version, and then I went and checked last night, and it's gone from cluster to in memory. I did not know that they had a cluster in memory version of MySQL. They make all these really wild claims on their website, and I haven't had time to really vet them yet. So just be aware that they exist, but I can't talk about them here. Okay, NeoDB. Um, Now we're getting into what's called these new SQL databases, right? So NeoDB, I don't quite understand it. It doesn't shard. It keeps a full copy of the database on every node. And I asked them about that. I wrote them an email. I was like, look, how are we not back to vertical scale? And they never got back to me. So I shook my head, crossed it off, and moved on. The two databases we have left, VoltDB and MemSQL. Both of these are pretty solid products, okay? There are some minor differences between the two, but there's one really big difference, which is why I picked MemSQL to play with over VoltDB, and the fact that MemSQL actually has kind of a hybrid approach to how they do in-memory. They've got an in-memory row store, just like all these other solutions out here, but they also have a column store where you can store data to disk. Now, here's the thing. When I was taking a look at this, this was my theory, and the theory is probably completely wrong, but I don't have a hardware background, and so my understanding of what's available for hardware is actually fairly limited. And so my thought was, okay, RAM is obviously more expensive than disk. Um, you can do horizontal scale all day long, but at some point there's going to be a cost benefit analysis in terms of how many machines you can actually have in your organization, and what happens if you've got more data than you have access to RAM. Okay, because my thought was also that there's an upward limit on how much RAM you can stick in a machine. I could be completely wrong about that because I just learned very recently that there are servers out there that have terabytes of RAM in them. So if you string these things together, you should probably have no problem sticking whatever data you got in memory, right? So um, this was months ago. The whole thing with the memory and servers was completely recent. So I went ahead and played with MemSQL and pulled it down. And how do I want to place this? Well, okay, understand. I'm not paid by MemSQL. I don't work for them, but I love the product. I really do. I love the database. It's very easy to work with. This is what MemSQL is, right? So it's built. So what? So what? I know I didn't have SAP HANA out there. There's a reason for that, and I don't want to. Yeah, there's a reason for it's not out there. Well, okay, here's the deal. Like I had SAP HANA out there, right? But I did not have it. But I also had Netezza and PDW, and it's in those same class of really expensive, solutions that IBM. No, not. Yeah, Netezza's IBM. Yeah. Okay, and this is a really good point. So when I was taking a look at all this stuff, I narrowed it down to VoltDB, MemSQL, and NoDB to take a look at because there's a list about this large in terms of solutions that are out there right now. So okay, yeah, no problem whatsoever. Really, I'm also not familiar with that either. So really, okay, okay, that's cool. So stick a pin in that. I don't want to take it because we have other presenters tonight, and I don't want to take up their time as well. So somebody stick a pin in that, write that down, and we'll come back to it. Okay, so this is what MemSQL is, right? So it's a relational database, right? So working with it is just like working with any other database that I've ever worked with, right? It's ACID compliant, so you don't have to deal with CAP theorem. Everybody knows what CAP theorem is, right? I'm seeing nodding head, so I'm going to move on. Let me back up one. So if the question is, how do we do big data over SQL? I think the answer to that question is, well, first of all, let's keep our data in a relational database in the first place, right? And so if we start from there, we start to gain back some of the things that we lose by moving our data over to Hadoop in terms of speed, in terms of those skill sets that we already have, in terms of like SQL and whatnot. We don't have to learn any new languages like Python or something else to work with Spark or something like that. So you don't need all that. You can work with MemSQL just like you work with any normal database. But here's the key point, is that last data point, right? With MemSQL, you can do mixed OLTP and mixed OLAP workloads together. That right there, that's our HTAP. That's how we get to our HTAP. That's how we get to real time. And how that works is that they use something called MVCC's multi-version concurrency control. That is going to be a element of a lot of these in-memory databases that are trying to do HTAP. And what MVCC is basically is that you got your readers and you got your writers, and basically they're fighting over the data that's on the disk, right? Well, if you've got someone that's writing data and you've got a long-running analytics workload, normally that would lock a database up. What MVCC does is that it takes the data that's on disk, it gives the reader a snapshot, and if there's a writer at the same time, it'll take that data and put it in a separate address location on disk or in memory or whatever, and it'll mark that as new. It'll mark the data that's being read as obsolete, so when the read's done, if there's another read after that, it'll point to the new version of the data, and that's how we deconflict our reads and writes. So basically, no more with no lock. Okay. Another cool thing is that it's a JSON data type, and you can take JSON and stick it into a SQL Server just by like making it like a blob data type, whatever. But the thing is about MemSQL is that they have a JSON data type where you can query the JSON from within your SQL statement, so you don't have to do any kind of special parsing to the JSON. Yeah, and another key point is they run the MySQL wire protocol, which means if there's a MySQL driver attached to whatever that you're trying to connect to, it'll work. It'll work with MemSQL. Okay, so and on this point, it's JDB ODBC compliant. I asked them specifically, does this product connect to Tableau? Right? They say yes. It most certainly does connect to Tableau. So that's it. That's our whole piece. We got the rapid ingest. We've got the mixed read-write workloads, and we have our analysts being able to get the data without having to go to the IT folks. Okay? That's the full stack of trying to do a in-memory or not, yeah, trying to do an in-memory real-time solution, right? And even if that wasn't cool, they also created something called a Spark connector, and that's basically it's a connector into Spark where that the people that are Spark users in your organization, your data scientists and whatnot, they can read and write our DDs to and from MemSQL without any problem just by using the Spark connector. And MemSQL is not a toy. One of their clients is Zynga, the people that brought you Farmville and other mobile gaming applications, right? Zynga is running a MemSQL cluster with 500 nodes. So even though it's not as mature as SQL Server, it's completely ready right now for enterprise installation. Okay. All your queries get turned into compiled code, which is something I'm actually want to talk about later when I do my demo. Let me check the time here. Okay. All right. Okay. So I recently finished up Rockhurst's data science program, which technically makes me a data scientist now. At least on paper. Yeah, at least on paper, right? it was 15 months, really hard work. But no, that was the problem, right? Okay, so during class they would like show us, and this is what you're gonna make as a data scientist, and I'm looking at these screens like I already make that. That's not motivation. So anyway, all right. So I had this assignment, the very last assignment of my data science program. What they wanted us to do is they wanted us to go out and get big data, which you guys heard me complaining about that earlier. It was very challenging to get my hand on some big data. So I found some, and at the same time that I got this assignment, I just so happened to be pulling down MemSQL and working with it. So I went ahead and installed MemSQL. It's a super easy installation. They've got some scripts that you can create interactively that go ahead that you basically the script will ask you information about your cluster. You input the information, you hit enter, and then that's it. 5 minutes later, you've got MySQL installed. Or for me, it was 5 minutes because I only have a cluster of 3 machines, right? And since I hate working with things via command line, I connected them with SQL using the MySQL connector, just like they say, and that completely works. Or no, connecting with Squirrel. Excuse me. Everybody knows Squirrel, right? It's just a okay. Squirrel is it's an open source. What should I call it? It's a SQL interactive. Like, okay, it's SQL Server, right? Yeah, it's a client for MySQL, or well, basically, it's a SQL client for any ODBC JDBC database. Okay. So I'm a huge nerd, and I have my own computer lab at home. I got my own computer lab because I don't trust the AWS pricing model. Like when I go out and I spin up an AWS instance, I'm never really quite certain what I'm getting what I'm spending. So I got my own machines to play with. I've got one Windows box, a standalone, where I do my traditional data work at, and I also have a cluster of 3 machines. All these machines I put together with basically chips to Micro Center. It's all off the shelf hardware, nothing special. All in cost plus my network upgrades for all that is probably like $1,200 max. Okay, so what I wanted to do is I wanted to go and see what are the speed differences between SQL Server and MemSQL, right? Those numbers are really small, but I had 47 million records of a table. It's like maybe 10 to 20 rows, I think. And I just basically ran a count star on it, right? And so the top one is the results in SQL Server. As you can see, that's an hour and 5 minute query took to return that. And the bottom query window is MemSQL. The exact same query on MemSQL took 9 seconds. Pretty cool, huh? Okay, well, I thought it was cool. Okay. All right. Yeah, sure. Sure, no problem. Yeah. Right, 9 seconds. Okay, and this is really interesting, right? Because this is actually the query being compiled into C++, and this would actually take to actually read the data. So if I would have done this again, that's probably what it came up to be. So I'm sorry, what were you saying? Yeah, and it's 47 million. 47 million records. Okay. Yes. It was 10 gig. In SQL Server, it took an hour and 5 minutes. No. Let me answer this question, okay? Does it even matter? Could you in SQL Server come up with a 9 second query over 47 million records? Really? I have not seen that. If you could prove that, that'd be fantastic. But this blew me away. So yeah, 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 yeah. This is not weird to me. When I would regularly work with data sets this size while I was at Sprint, these are the kind of results I would get. It would take a half an hour to hour to pull back, information on all subs. Last time I checked. So what? They're not too. You talk to them about that. Okay. All right. I'm moving on. Okay. Um, I'm going to come back to this. Okay. Okay. I want to jump into the demo. I'm sorry? No, no. I wish I wish I was. It'd be really easy to get around this town. uh, okay. Basically, what I want to do now is I just want to show you how MemSQL or another in-memory database can help you clean up your data architecture, right? So I was at a client, and this was their data architecture. So they had an application that was powered by Node.js, and their application ran. It was a web application, and it ran off a Postgres database. If they wanted to do analytics on the application, they took data and they dumped it out to MongoDB, and that's where the engineers they did some operational reporting on what people were doing in the application. And they also had a different stream, which was the exact same stream of data, and they dumped that out to RabbitMQ off to a NoSQL data store called Event Store, which I'd never heard of, which is basically it's a document database. I'd almost call it a time series database. But the data that was coming out of the application would collect an event store like a bin or a silo, and then there'd be this piece called the event ETL, which was some custom C# code that pulled the events at a set amount of time into a staging area in SQL Server, and then at that point it turns into a traditional batch ETL process that ran overnight, right? So, um, rather complex, probably a little bit over engineered. What is really interesting about this is that if you take a look, the data flows that come out of the application for analytics actually are not coming out of the database. They're out of Postgres. They're actually coming out of the application. They're being casted out as events in JSON. And what's that? That's a log, right? And so they built this without like any knowledge of anything of what I just talked about. They kind of did it intuitively. And so I wish I knew all this stuff back then. But something like this setup is right for basically everything that we just talked about. So, um, what I want to do very first off is to replace SQL Server as the warehouse and replace it with MemSQL, right? Because I want those simultaneous read writes. And in the event ETL piece, instead of having that being a batch process, I would turn that into a real time process where I would suck everything out of event store like at real time. I would skip the staging area and just start throwing stuff right into data warehouse tables. Now, for me, that's good. I'm done. I want to stop at that point, right? But it turns out that I actually kind of lack creativity because we can actually go further with this. Next step, okay? I would replace Kafka, or I would replace RabbitMQ, and I would replace Event Store with Kafka because that basically, did the job of those two pieces of software. And I would use Storm for CEP. This is kind of a knee-jerk reaction. Go ahead. Complex event processing. Right. So when you're doing ETL, whatnot, it's not just throwing data into tables. You got to sit there and pump it up against your master data management. You got to clean it up and do all that nonsense. It's not just a one-to-one. You got to do work on it first, right? So Storm will do that for you. Here's the thing. So Kafka and Storm, everywhere you look for real-time processing, you're going to see probably those two pieces of software, and that's cool and everything. But those two pieces of software need to be sitting in their own clusters, and at a minimum, there needs to be 3 machines. And there's actually a piece missing that I realized this morning that Zookeeper needs to be in this as well, and Zookeeper also needs to be in its own cluster. So right now, with a minimum of like 4 machines, or excuse me, 5 machines for MemSQL, and 3 machines for Kafka, Storm, and Zookeeper. What we're talking about 14 machines just for this stack alone, and that I think that's probably a little bit overkill, and especially in terms of cost, because even though those are commodity hardware, money's money, right? So if we can simplify that, let's try and do that. Third iteration, right? So we can get rid of Storm, and we can actually get rid of Kafka as well, theoretically, right? So this is what the folks at MemSQL say that you can do. Especially if you work in a situation where, especially at this organization, where the engineers were in one area and I was only responsible for analytics, and I really had no power to change the engineering side of the house. And so I could control my side, the analytics side. And so what the people at MemSQL say is when you have that situation, just have the application write out to data flows, okay, like it currently already is, right? The problem I have with this is that now the application has to be responsible for putting stuff in the data warehouse, and I really don't know how practical that actually is. It doesn't really sound like it's practical. It sounds like a lot of extra code in your application. It doesn't sound like an optimal deployment at all, right? But it's an option. You can totally do this. Okay. Now here's the ultimate. Now this is what all the in-memory folks are selling to you right now. This is what they say that you want to do. You want to take all that stuff and just stick it out of one database, right? Um, question marks with this stuff too. There's 3 questions I have. So if you did something like this, where you placed everything with just MemSQL and had reporting done out of MemSQL without all the extra stuff, okay? The application now also has to be responsible for putting stuff in a data warehouse. But is it really a data warehouse? Because really the application still has to do what it's supposed to do, right? But that's going to be a third normal form relational database. Is a third normal form relational database really the optional database to have somebody doing analytics out of? Okay, do you really want to have a whole bunch of historical data in your application, the persistence layer application? If you don't, then there's the option of taking and putting that in a different database. But now we're back to 2 databases. So what was the point? And then there's the larger philosophical issue of if this is the future, if this is the way that we're going to do things in the future, where we have OLAP and OLTP happening out of one database, then what is the purpose of Kimball? And does the Kimball method even have a future, right? So I don't have answers to those questions. Those are just questions that are hanging out there. There are people in this room that work on stuff like this all the time. This is all pretty much there for me, except for my little 3 node cluster at home. So if you got thoughts on that, they're definitely welcome. Like I said, you can email me them. Um, right, it's storing for analytics, it's storing historical data. So then my question is, like, you don't want to have a Starskeeper to run your application off of, right? But you don't want to have a third normal form database doing your analytics out of. So exactly. Really, okay. Here's my problem with third normal form for analytics. There's so many tables that are involved that it makes the work for analysts really difficult because of all the tables that you have to join just to get a decent answer. So that's not optimal. Yeah, exactly. No, that's completely accurate. It's just about the application. Forget the analytics. It's all about the application. Yeah. It's okay. You can think about it from the application. This is my approach. If I walk into an organization with legacy stuff, you would slowly replace the legacy stuff over time with the new, like real time stuff. Um, but I think probably the optimal would be for me personally. Like I would prefer to go into a startup where I could get in there from scratch before they start wrecking stuff up. Yeah, SSDs. Yeah. So on my food for thought slide, like my fast bullet point there is that okay. So the problem with speed also is disk I/O, right? And so could disk I/O be alleviated with the SSDs? No, no, I have not had that opportunity yet. So the first chance I had was my buddy, and I talked to him about it, and the managers were too far down the path of PDW to get them turned around towards something else. So yeah. I would like to position myself in this town as like somebody who can be a go-to for this, but it's going to be a problem in terms of just like every technology, letting people know that hey, this exists and you can actually do it, and you probably should be doing it. Write the check, please. Really? But it's like that though. It's yeah. Yeah. So, if you guys got any technical questions that I did not ask, their documentation is out at developers.memsql.com, so you can go out there. If you got any questions, um, I've been working with our tech support folks for several months now, and they never asked me for a dime on anything. So they're completely open and willing to help you with any problems that you might have with the software, any questions you might have. So that's all I got. Any additional questions, comments? Okay. Thank you. I will yield the floor.